Okay. Good morning. Good morning to everyone. We are going to see today wave optics, third chapter in second year physics. This is one of the most important topics which we are having regarding this light. We have already discussed in the previous chapter about light and its origin. And we have some discussed mirrors and prisms also. While discussing all these and also instruments which are we are using optical instruments, periscopes and microscope, all these are based on ray optics. We have already discussed the chapter. Ray means a straight line direction. Generally, the light has to travel. They feel in previous in olden days they felt that light has to originated from source, and after this originated, propagation of light is in a straight line, just like a line. So that is called ray optics. But this chapter, we will go to further about the details of the propagation of light and also a new theory, Huygens wave theory. Newton, Huygens, and Max Planck, these are the prominent scientists who put forth theories regarding nature of light. Here, when compared to sound, the velocity of light is very, very high. We know 3 lakhs kilometer per second. It is very high when compared to velocity of sound is only 330 meter per second. So the velocity of sound is very high. So the how to understand the nature of the light, how it is traveling, and which media it is moving, that is very difficult for the olden days. Number of years they are trying to struggle to find out which is the correct way, which is the what is the process of propagation of light. One thing is its velocity is very high. Another thing is sound can travel through medium only. But as far as the light is concerned, we are getting light from sunlight. Means in daylight we are getting all this light from sun and stars. It means light can travel through vacuum. What is the medium between sun and earth? If you feel it is vacuum. So even though it is vacuum, light can travel. But as far as sound is concerned, sound travel only in medium and its velocity is very less. Therefore, the nature of sound and all these easily we can find. But as far as light is concerned, it is very difficult to find, to detect the nature and propagation. So, number of scientists tried. Newton developed corpuscular theory, a new theory. Only all these three theories are imagined. Exactly, there is no proof for them. They are imagined, and after that, they will discuss about the different theories. One of those most important one is corpuscular theory. What does it mean? Corpusculars means very teeny small particles. Very small particles. Light has to start from source in the form of particles. This is developed by Newton. Why he has taken these particles? Whenever we are talking about a particle, generally the nature of light we are talking about, some properties of light are concerned. At the time of Newton, what are the properties of light? Generally, all of you know, at that time light originated from luminous body, first thing. Second thing is it can travel in straight lines. Why? Because shadows are formed. Shadows are forming due to straight line propagation of light. So that is also well known to everyone. And third one is different colors of light: blue color light, green color light, red color light. So colors of light is already existing. So these are the general properties. Without scientific knowledge, we can tell light is traveling rectilinear propagation of light and colors of light, and also reflection. Some opticals, some objects are placed in the path of the light, it can reflect. That is also known. And refraction, sometimes the light has enter into it, just like water and glass. Some media is placed in between the propagation of the light, then immediately it bends. The bending of light is just, we call it as a refraction. Sometimes it comes back in the same medium, it is called reflection. So refraction, reflection, and also colors and rectilinear propagation. These are the four general, and also most important, already we have discussed, the velocity is very high. It is already known. These are the 5 important properties at the time of Newton's development. So based on these, he developed his corpuscular theory. Corpuscles means very small. Corpuscular theory explains the velocity of light. How? Corpuscles means very small. So first he tried to explain the rectilinear propagation. Why the light is originated from the source and traveling in the straight line? What is the reason? According to it, he is telling particles are very small, tiny particles, no gravitational force acts on. These are purely elastic, very small, no gravitational force acts on these particles. So by telling these conditions of the particles, the particle does not bend. This particle does not bend due to the gravitational force. So they will travel in straight line from the origin of light source. Okay. Now, what are the reasons for colors? Different colors, blue light and green light, red light, how he can explain? He could try to explain the size of the corpuscles. These small particles are known as corpuscles. Their corpuscle size is different for different colors. Blue color corpuscle size is different from yellow color is different from red color. Like that, different colors have different sizes of corpuscles. So by telling the size, he explained colors. And next, how it is taken reflection. Some when the light is incident on certain objects, the light enter into the same medium. It does not passes through that objects. Why? Means the objects have certain small corpuscles, and light is also corpuscles. These particles, object particles and light particles, which we are talking as corpuscles, these two repulse each other. There should be repulsive force acts between these two particles. That's why when the light is falling on this object, immediately it returns back. This is called reflection. He explained by the repulsive force between the particles, he explained reflection of light. And next property is refraction. Sometimes if you take a glass or water or some liquids, light enters into the particular object. Why? This is explained by the liquid or water consists of particles. These particles and corpuscles of light have attractive force. Due to this attractive force, these will enter into the medium. He explained like that. So due to attractive force between the particles, he explained refraction. Due to the repulsive force, he explained reflection. And due to sizes of the particles, he explained colors. And it's elastic, purely elastic, no gravitational force acts on the particles. By explaining this, he explained rectilinear propagation of light. So he explained on these. And also, all of you know, this bending takes place means the velocity of light or speed of light in denser medium. Whenever light enters into the denser medium, its speed decreases. But that is actually what we are knowing today. But according to him, why he is telling this refraction, how he explained refraction means by taking attractive force. Therefore, when the light ray enters on water or glass, immediately the glass particles attract. Already the corpuscles have certain velocity. And also when they are entering into the medium, the particles attracts with a higher speed. Therefore, what happens? This attractive force increases the speed of the light. So he explained the velocity of light in a denser medium is greater than. Why it is greater? Means due to attractive force. Greater than in the rarer medium. From air, for example, air is a rarer medium. Glass is a denser medium. When light is entering from air to glass, immediately its velocity increases. Why? Due to this attractive force of the particles. Corpuscles are attracted by the medium, therefore its velocity increased. These are the points. This is called corpuscular theory of Newton. This theory could not explain some important things. Those two. What are those? Interference and diffraction. Diffraction and interference are the two different phenomena of light. At the time of Newton, while giving this corpuscular theory, the interference, formation of interference patterns and discussion and diffraction is also identified. But he could not explain with these corpuscles how interference takes place. Actually, superimposition of waves is explained by interference. Next, we can discuss about that. At that time, in 1678, Christian Huygens, a Dutch scientist, put forward a new theory. This is called wave theory. He started a new theory, wave theory. All of you know Earth is revolving around the sun, today. In the olden days, geocentric theory is there. That is, Earth is the center, sun is revolving around the Earth. That was believed. This is a wrong theory. Even though it is a wrong theory, 1400 years it should be in the presence. What is the reason for it? Why it is existing in these 400 years, not only 2 or 3 years, even though it is quite wrong theory. Why? Because there is no exact proof for these assumptions, one thing. Second thing is, what are happening for formation of eclipses, all these, exactly according to time, it is occurring. Therefore, no doubt about it. They are believing it. Understand? So, similarly, Newton corpuscular theory is existing at that time. At the same time, Christian Huygens proposed a new theory, wave theory. What does it mean? Wave means the light originated from the source and travel in the form of mechanical waves, in the transverse wave form. So there is a complication here. Actually, when this was proposed by Christian Huygens, a question arises. We have already started the chapter second year physics with waves. Whenever there is a wave, what is wave? Wave means a disturbance created due to the energy in the medium. This disturbance is transferred from one place to another place. This is wave. Now, Christian Huygens is telling the wave theory. Okay, wave theory means there should be a medium. What is the medium between sun and earth? Question arises. Whatever the name he is telling, there is no medium existing. So Christian Huygens, some problem arises. This problem he has imagined an imaginary. Generally, we will take in mathematics the amount he has having X rupees in his pocket, and after calculation we will find out X. What is X? That is, just to find out the remaining, we are taking X as a primary basic one. Similarly, he has taken X type a medium which he has called ether. A medium is existing, ether, in the universe. So while you are talking, it is existing in the universe, there is no question arises from sun and earth, the light rays will come. No problem for them. These light particles, he is not telling about particles. He is taking as waves. These waves travel through this medium, that is ether. In next days, some scientists not believe this ether, even though there is no medium like that. At that time, what they are discussing, there are different colors, different refraction, reflection. All these properties he can successfully explain. Waves can travel in straight lines. So rectilinear propagation he can explain. And light can enter from one place to another. In wave theory, waves can enter or reflects, takes place. So easily, successfully he can explain all these refraction and reflection. The most important prediction of this wave theory is the velocity or speed of the light in denser medium is less when compared to that of rarer medium. That is one of the most important prediction, which is quite opposite, which was proposed by Newton's corpuscular theory. According to Newton theory, denser media velocity of light is more, whereas according to Christian Huygens wave theory, here the velocity in denser medium is less. So there is a controversy between these two. Some scientists are Newton theory is correct. Some scientists believe in wave theory. They are going some more experiments. And finally, Foucault, a scientist, conducted experiments and find out the velocity of light accurately. That is 2.78 into 10 power 8 meter per second. Exactly whenever he find out the velocity of light, not only finding out velocity of light, he can find the velocity of light in different media. In water, also he find out velocity in glass, in water, and different liquids he used. In all these, he finally concluded that the velocity of light or speed of light in denser medium is less when compared to that of rarer medium, which supports the wave theory, Huygens Christian wave theory. This is a great blow to the Newton's corpuscular theory. Whenever it was proved experimentally, all the scientists come forward to believe in wave theory of light. This is the actual history of the wave theory, Christian Huygens wave theory or Newton's corpuscular theory, a controversy about these two. That what we have taken in this, the velocity of light was first determined by Galileo in 16th century. Later, Romer, Bradley, and Fizi determined the velocity of light. These are not exact values. Approximately, they try to find out. In 1862, Foucault devised a rotating mirror method. He used a rotating mirror method to determine the velocity of light in more accurate compared to the above scientists how they are measured, the other methods. It is 2.98 into 10 power 8 meter per second, almost 3 into 10 power 8 meter per second, what we are generally we will use. So this is not only accurate method, this is the importance of Foucault experiment. Not only accurate method to the velocity of light, but also the velocity of light was determined in water and other liquids also. Foucault experiment proved that the speed of light is less in denser media. This is the most important observation proved by the Foucault's experiment. Speed of light is less in denser media than in air or rarer media. This experiment results supported Huygens wave theory of light. So we are discussing about what is Huygens wave theory. While going to this Huygens wave theory, we have to know some important one. Sorry, a wave front. What is a wave front? It is a locus of all points of the medium which are in the same phase. Generally, the locus are all the points with same phase from the source of light. If you take a point source and from this point light source, you observe same phase of particles. Joining all these particles, you can get a sphere. We can get a sphere. The center of the sphere, you can imagine light source. So wave front means three-dimensionally you have to understand wave theory. That is most important. As in case of ray optics, we are taking one line, which is light is traveling in the form of a line. But here we should remember not a line. Even though you are drawing lines, you have to imagine these lines as planes. So three-dimensionally, we have to going to explain the wave theory. So beginning from this, wave front, we are always talk about wave front. Wave front means three-dimensionally a sphere we have to imagine. A wave front is the locus of all points of the medium which are in the same phase. It is defined as a surface of contact, constant phase. Okay, all the points on this wavefront are same phase. And joining all these, we can get a surface three-dimensionally. So the equidistant points from the point light source is a diverging spherical wavefront. You can imagine a light source as a diverging spherical wavefront. It is known as spherical wave. We call it a spherical wave or plane wave. Plane wave means we have to imagine just like a paper. A paper is called paper-like light is called plane wave. Now, what is the principle? Huygens wave theory tells every point on this wave front, which we are talking about, wave front is a three-dimensional sphere of light. Every point on this sphere acts as a secondary source of wavelength. So he is trying to tell how the light is transmitted in rectilinear direction, rectilinear propagation of light. Always the wavefront moves in forward direction only, does not come back. So while they are going in forward direction, first what we have taken a primary wavefront. We have taken a light source and at a smaller distance, you can imagine a sphere. That sphere is taken as primary wavefront. From this primary wavefront, how it will move forward, the light, how to transmit it from other directions. He explained every point on this sphere, light sphere, we have to imagine a light sphere is a wavefront, spherical wavefront. So every point, whatever point you consider, all these points acts as source to the another wavefront. These secondary waves travel whenever each and every point acts as a source, and again they will travel in a forward direction. Like this, all these secondary waves travel in forward direction only with the velocity of light as the primary wave. In which media you are observing the primary wave, the secondary wave also formed in the same medium is same. Therefore, the velocity of primary wavefront and the velocity of secondary wavefront are same if you are observing in the same. Generally, for example, if you are considered as light in air, velocity of light in air, how much velocity it is, the same velocity is maintained to primary wave and secondary wave. This is the most important point we should catch it. Why? Because while you are observing the secondary wave far away distance from the primary wave, you may think its velocity may be decreased. Don't feel like that. In the same medium, you are considering secondary waves. Whatever the velocity to the primary wave, the same velocity is existed to the secondary wave. The velocity does not change. To tell that, he pressed this point. So what is the principle? Every point on the wavefront acts as a secondary source of wavelets. We call it as wavelets or wave. These wavelets, these secondary waves travel in forward direction only with the velocity of light as the primary waves. So these two important sentences are the principles of Huygens wave theory. Let us try to understand the three-dimensional explanation of this Huygens principle. You can see in this figure. Point source. Here O is the point source in the diagram, you can see. Primary wave arc we have considered a circular portion of the sphere we have taken. Don't think it is an arc. Three-dimensionally it should be a sphere. From the part of the sphere we have taken here as an arc. So AE, A, B, C, D, some AE is called a primary wavelet. First wavelet from the source O, we are considered. Arc AE represents a portion of spherical wavefront at any instant of time. It is primary wavefront. Now, all the points, what are the points on this? A, B, C, D, E on this arc acts as secondary wavelets. According to principle, all these are secondary wavelets. What does it mean? If C is velocity of primary wave, generally we have considered air. So velocity of light here, c is considered. After t second, what is the secondary wavelength? These travel a distance. How much distance the A point will travel after time t? Velocity into time is the distance. Therefore, velocity of primary wave or velocity of wave is c. Time is t. After ct, it will travel at a distance of the radius, a smaller portion of a circular one you have taken here, A dash. The A has to travel a distance of a smaller portion. Okay, A dash. And B traveled up to B dash. We should consider an arc. A is the center. Actually, the diagram exactly is not correct. This A is the center. We have to draw the circle. Arcs you can imagine instead of circles. A dash along A dash should be on the perimeter of the circle. A is the center. Similarly, B is the center, and we have to draw a circle with BB dash. So, what is the length of BB dash? The radius of the circle is exactly CT. Similarly, CC dash, that is the length of CT. Like this, all the lengths D dash, E dash, like this. A new arcs you can put A dash, B dash, C dash, D dash, and join all these points. Joining all the points, we have to draw a tangent. Construct the arcs of radius CT as A, B, C, D, E as centers. So after drawing a tangent, the envelope all these arcs, A dash, B dash, C dash, D dash. What are these A dash? A new point from A to A dash. What is B dash? A new point from B to B dash. Similarly, C dash, D dash, like this. You join A, B dash, C dash, D dash, and E dash, all these. Again, you can get another wavelet. This is called secondary wavelet. This is called secondary wavelet. First, initially, A, B, C, D, E. These are primary wavelet. AE is the primary wavelet. On this primary wavelet, we have taken A, B, C, D, E some points. Each and every point acts as source to another secondary wave. Source to secondary wave. So you have to draw arcs. This radius is exactly length of velocity into time, c into t. After t time, a new wave is A dash, E dash. This is explanation for Huygens principle. Can you understand? I think you can follow. Now, let us say refraction of Huygens principle. We have already discussed about the Huygens wave theory. How did he explain refraction and reflection? That is our lesson today. You see in this diagram, PP dash is a separated media between these medium 1, medium 2. Refraction takes place when light travels from one medium to another medium. So let us take medium 1 is upper portion and medium 2 at the down we have taken medium 2 at the lower portion. And the velocity of medium 1 is taken as V1, velocity in medium 2 is V2. You see in this diagram. And here, let us take first a wave front, incident wave front, that is AB. Okay, according to your ray diagram, you can draw A dash A. To understand easily, we are taking this A dash A and some B dash B. Those are just lines you are taken. Actually, A dash A, B, B dash, this total, it is a wave front. It is a plane. It is incident on PP dash. While it is falling on this medium 1 to medium 2 at a certain angle, it is coming. Imagine while it is coming like this, when it A portion, A point touches the PP dash, the surface of separation, you should remember this PP dash is perpendicular to this paper. You should imagine it is perpendicular to this paper. And also this AB is also perpendicular to the plane. As these are planes, you should imagine three-dimensionally these two planes are perpendicular to each other. Like that they are coming. So if A point is first touches the PP surface. But what about B? B is not touching the surface. When A is touching, immediately it has to enter into the second medium. According to its velocity, when A, B, both these two are in air, the velocity is same, V1 and V1. A point and B point we are considering on the wave front. We are not taking all the points, only 2 points on the wave fronts. To understand refraction by Huygens theory, we have taken A point touching the surface first, and it has to enter into the second medium with which velocity? Velocity V2. So with velocity V2, it moves into second medium. So after time t, what is the position of B and what is the position of A? After touching, whenever A is touching the surface, t is equal to 0. Now, after time t seconds, what is the condition of A and condition of B? Let us see now. After t seconds, A has to travel in the second medium at a distance of V2 into t. Understand? V2 is the velocity in the second medium, and time. Velocity into time is distance. Let us consider that distance is AE. AE distance it will enter. At point A, we have taken a normal line. While you are drawing a normal line, angle of incidence is shown as normal, and the incident ray AA dash with the normal makes an angle of I. Similarly, inside the medium, AE is the refracted line, refracted ray, according to our understanding of ray diagram. AE is the refracted ray. Therefore, the refracted ray makes angle R, that is refracted angle. Now, what is the condition of this B? How this A is entering a distance of AE, we have shown a arc at the E point, you see, means A, according to Huygens theory, A is a source of light, and we have to draw an arc at a radius of V2 into T. So like this, joining all these points on this arc, we are getting secondary wave from A. So that is AE. Now at the same time, B enters and touches the C point during the same time t. What is its velocity? B velocity is V1, as B is in the medium 1. So its velocity V1, and the time, same time we have taken t. V1 into t is the distance covered by point B in medium 1. So it moves at a distance of C. Okay. Now, if you consider two triangles, ABC, now we are going to observe geometry. By this geometry, easily you can understand. At B, it is 90 degrees in ABC triangle, and angle BAC is angle of incidence. Why? Because this normal, let it be N, NAP is 90 degrees. In the medium one side, that angle is 90 minus I, and the remaining this side is 90 minus I. That's why the portion angle BAC is I. As incident wave front and the normal also makes same angle I. Okay. And in the triangle AEC, which is in the second medium, in this triangle, you can consider how much values these are, where is R. This is R already taken, angle NAE. You can imagine NAE is, or N dash AE you can take, where NN dash is the normal, not written here. So N dash AE angle is R. So whenever arc and radius, AE is the radius, therefore angle AEC is 90 degrees. Angle AEC is 90 degrees. So what is angle EAC? Angle EAC is 90 minus R. This is 90 and angle EAC is 90 minus R. What about angle ACE? Exactly, it is R. Why? Because the sum of the three angles should be 180. 90 plus 90 minus R plus X. Let us imagine it is X. So this total you are calculating, which is equal to the sum is 180. From this you can get angle ACE is R. Angle ACE is refracted angle. So let us see what we have discussed. That drawn here, explained here, PPT represents the surface separating medium 2 and 1, medium 1 and 2. Let V1 and BT represent speed of light in medium 1 and 2. A plane wavefront AB is moving in the direction of AA dash. Its angle of incidence on the interface is angle I. The point B touches the surface at C after time t, and BC is equal to V1t. Draw a sphere of radius V2t from the point A to determine secondary wave from A, what we have discussed. Now, finally, we have to see, consider the triangles ABC and AEC. From those two triangles, what is angle I? It is better to note down the diagram. From easily you can understand. Angle I is BC by AC. And sin I and sin R, AE by AC. You see that diagram? From that, you can tell sin I is equal to BC by AC. What is BC? BC length is nothing but V1t, velocity into time, and AE, distance is V2t, and V1t by V2t by AC. So sin I by sin R, you can get V1 by V2. That is refractive index of that one. If R is less than I, the speed of light wave, you see the diagram, R is less than I we have taken. So the speed of light wave in the second medium will be less than, that is that THAN, than that of medium 1. This prediction is opposite to corpuscular theory of light. So according to this, sin I by sin R should be a constant, V1 by V2. V1 is a constant one, V2 is a constant one. V1 by V2 should be a constant, means R should be less than I. Therefore, this indicate V1 by V2 is constant, indicate R is less than I, means in which the angle R is in the second medium. Therefore, in the second medium, velocity is less. In the first medium, sin I is taken in the first medium. So the velocity of first medium is more than the second medium. This is what we have already discussed. In a denser medium, the velocity is less. Let us see refractive index. If you see represents the speed of light in vacuum, what is N1? N1 related to rarer medium. N1 is equal to C by V1, velocity of light in vacuum by velocity of light in the medium. Similarly, what is N2? N2 is equal to C by V2. From this, what is V1 and V2? V1 is equal to C by N1 and V2 is equal to C by N2. So, if sin I by sin R is equal to V1 by V2, substituting that, V1 means C by N1 and CC get cancelled out, then you can get this Snell's law, N N1 sin I is equal to N2 sin R. This is Snell's law of refraction is also proved according to Huygens wave theory. And here BC by AE, which is equal to V1 by V2. Is it not? V1T by V2T, TT get cancelled, V1 by V2, which is equal to delta 1, lambda 1 by lambda 2. What is this lambda? Nowadays, we know what is this lambda. Lambda means wavelength. The distance can be converted into wavelengths. So you can write BC is waves in medium 1. That's why it is lambda 1. And AE is the second medium. That's why it is taken as lambda 2. At the time of Huygens wave theory, he don't know the wavelength, the word wavelength. Even though after that, the wavelength is invented, the name invented wavelength, and finding out wavelength, we can tell the spectrum, the visible spectrum wavelength, the red color, X-rays, all these are represented. Whenever there is a wave, it should have wavelength. So according to this, V1 by lambda 1 is equal to V2 by lambda 2. What is the importance of this equation? This equation implies when a wavefront get refracted from rarer to denser to rarer to denser medium, its speed decreases, but frequency remains constant. Frequency does not change. We should remember lambda V1 by lambda 1 and V2 by lambda 2. Here the ratio indicate V is equal to nu lambda. Therefore, these two, nu 1, nu 2, you can write. The frequency does not change even though the wave velocity increases or decreases. The constant factor when refraction takes place is frequency. This is our lesson today. This is Huygens wave theory. According to Huygens wave theory, how the Huygens wave theory is originated, what are the theories already existing, and what is the difference between Huygens wave theory and already existing Newton's corpuscular theory, and how he explained all remaining all refraction and reflection. Tomorrow we can see how did he explain reflection also. Here we have taken refraction, and next class we can see how did he explain the reflection, and we will see the some other details based on Huygens wave theory. That's why it is wave optics. Thank you for all to listening me, joining with me. Thank you for all. Thank you. This is the end of this lesson today.